Only work on the high voltage systems if you have been trained and are confident to do so and all safety guidelines are fulfilled. In this video, we replace the electric drive motor bearing, a common wear item on this vehicle, with high quality febi replacement parts. These parts are not available from the vehicle manufacturer. Before working on any high voltage or associated components on a hybrid or electric vehicle, the de-energization procedure must be carried out for your own safety. First, place a high voltage warning sign on the vehicle to warn others in the workshop that you are working on the high voltage system. Turn off the ignition and remove the ignition key, storing it away from the car, then disconnect the 12-volt battery. The traction battery service plug is in the luggage compartment. Wearing insulated gloves, remove the surface plug and store it in a safe place. Then wait at least 5 minutes to ensure the high voltage capacitors in the inverter are fully discharged. With the vehicle raised, remove the plastic covers and disconnect the inverter cable. Then check the voltage at the high voltage cabling plug terminals to ensure that the residual voltage in the circuit is under 30 volts before continuing. To remove the drive motor, first drain the coolant from the radiator, then remove the coolant pipes from the motor and allow to drain. Disconnect the high voltage orange wiring harness from the motor and the black sensor connector. Then remove the mounting, supporting the motor assembly with a transmission jack. Once removed, locate and unscrew all the motor bolts which attach it to the transmission and separate the two major components. Then carefully lower the motor from the vehicle and transfer it to a bench. Place the motor assembly with the rotor position sensor side facing upwards, then, ensuring appropriate support is provided, remove the 4 bolts and take off the upper cover. Next, disconnect the 3 high voltage cables. Remove all the bolts securing the end cover, noting the different lengths for reassembly, then carefully prise off the cover, which is held in place with sealant. Remove the high voltage connectors from the stator along with the connecting block, then disconnect the wiring for the resolver and motor temperature sensors, separating the 2 cables. Remove the resolver sensor from the motor, marking its position for reassembly, followed by the encoder. Next, remove the housing retaining bolts. Using a rubber mallet, evenly strike the housing to release the bearing and encoder from the rotor until the housing can be removed. Then remove the gasket. Turning the motor over, remove the seal from the output shaft. Then take out all the retaining bolts from the housing. Supporting the motor housing, slide the rotor out of the stator and remove the gasket. To remove the bearing from the output shaft end, remove the circlip and then, using a hydraulic press, push the rotor out of the housing cover. Working on the bench, remove the 3 retaining bolts from the bearing plate and extract the bearing. Clean all mating surfaces and lightly oil the housing, then insert the new bearing by hand. Refit the bearing plate and tighten the 3 bolts to 15 Newton meters. Then press the new bearing onto the rotor. Moving back to the bench, refit the output shaft circlip and install the new seal and O-ring included in the kit. Turning it over, carefully slide the stator assembly with the new gasket over the rotor, ensuring the 2 parts align. Then, working on the other part of the housing, press the old bearing out. Then take the two assembled parts of the housing to the press and push the new bearing onto the rotor shaft, followed by the encoder. Install the housing with gasket over the new bearing, threading the wiring through the dedicated areas. Then refit all the housing bolts, tightening to 42 Newton meters. Refit the resolver and tighten the 6 retaining bolts, then rejoin the wiring to the temperature sensor and reconnect. Remount the high voltage stator cable block and tighten the cables to 10 Newton meters. Turn the motor on its side and install the housing bolts, tightening to 42 Newton meters. Then return to working on the sensor cover. Before assembly, ensure all mating surfaces are clean and free from old sealant. Apply new sealant and remount the sensor cover and evenly tighten all retaining bolts to 11 Newton meters. Followed by tightening the 3 high voltage cables to 10 Newton meters. Next, apply sealant and refit the upper cover, tightening the bolts to 11 Newton meters. Before installing the motor back into the vehicle, ensure the rotor turns freely and carry out an installation test using a suitable meter. Transfer the motor to a transmission jack and refit the motor to the transmission, tightening all retaining bolts. Refit all coolant hoses and wiring connectors to the transmission. Then reattach the high voltage cable to the inverter and lower the vehicle. Install the traction battery service plug and reconnect the 12-volt battery. Fill the coolant system with fresh, low-conductivity coolant, then carry out bleeding process to expel the air using a suitable diagnostic tool. Once completed, lower the bonnet, switch on the ignition and engage drive. When the vehicle moves for the first time, a warning message will appear on the instrument display. Check any system messages for the electrical vehicle. Fault code POC17 will be stored in the control unit. The vehicle requires to be driven at a speed of 20 to 50 km per hour until the resolver speed sensor has been calibrated. The fault message and code will automatically be erased if calibration has been successful. With the new motor bearing installed, this electric vehicle is back to being quiet and smooth in operation.